March 17th, 1943, 0900 hours, Rechlin, Germany. Oberst Werner Baumbach stood on the tarmac of the Luftwaffe's most secretive testing facility, watching a Boeing B-17 Flying Fortress taxi toward him. German national markings painted fresh over American white stars. The aircraft bore the code letters DL plus XC. The bomber's 4 Wright Cyclone engines thundered across the airfield. Baumbach felt the sound in his chest. 3 months earlier, this aircraft had belonged to the United States Army Air Forces. It had carried the name Wolf Hound painted on its nose. It had flown from Molesworth, England, with the 303rd Bomb Group. Now it was about to reveal every secret the Americans had built into their daylight bombing strategy. The pilot bringing the B-17 to a stop was Hauptmann Hans-Werner Lersch, test pilot, former fighter ace, one of the Luftwaffe's most experienced evaluation officers. Lersch had flown everything Germany, produced Messerschmitt Bf-109s, Focke-Wulf FW-190s, even captured Soviet aircraft. But this was different. This bomber represented a fundamental challenge to German air superiority. The Americans were building hundreds of these aircraft. They were training thousands of crew members. They were preparing to fly them deep into Germany in broad daylight. And German intelligence indicated the B-17 possessed defensive armament unlike anything the Luftwaffe had encountered. Baumbach had seen the preliminary damage reports. B-17s shot down over France and the Netherlands. German fighter pilots reported intense defensive fire from multiple positions. Some pilots described approaching a B-17 formation and facing what appeared to be a wall of machine gun tracers. Other pilots reported that isolated B-17s, separated from their formations, fought desperately until ammunition was exhausted. The bomber's nickname, Flying Fortress, was not marketing, hyperbole. It was a tactical reality. The B-17 that now sat on the Rechlin tarmac had been forced down on December 12, 1942. Lieutenant Paul Flickinger had been piloting the aircraft during a mission to Romilly-sur-Seine, a Luftwaffe servicing base 60 miles southeast of Paris. German fighters from Jagdgeschwader 2 had damaged the bomber's No. 3 engine. Flickinger held formation as long as possible. But the damaged engine was losing oil, temperature climbing, power failing. He dropped out of formation and headed northwest toward England. That decision sealed the aircraft's fate. Isolated B-17s died. German fighter pilots knew this. They could concentrate their attacks without worrying about defensive fire from other bombers in the formation. A Messerschmitt Bf-110 night fighter from Jagdgeschwader 1 intercepted Flickinger's crippled bomber over the Netherlands. The night fighter pilot, flying in daylight, positioned himself carefully and hammered the B-17 with cannon fire. No. 1 engine caught fire. Hydraulic lines severed, control surfaces damaged. Flickinger had no choice. He put the bomber down on Leeuwarden airfield. Wheels down. Hard landing. The aircraft skidded to a stop. Flickinger and his crew were captured. The B-17 was intact. German salvage teams moved fast. They wanted this aircraft to be flyable. Previous B-17s had been examined, but most were too damaged for meaningful analysis. One crashed B-17 had been reassembled at Rechlin in October 1942. That wreckage provided valuable information. Field Marshal Erhard Milch, State Secretary for the Luftwaffe, had examined the wreck and immediately understood the implications. He told Reichsmarschall Hermann Göring that the Americans were building a bomber capable of reaching Germany at altitudes German fighters struggled to reach, with defensive armament that made conventional fighter attacks extremely dangerous. Göring dismissed Milch's concerns. Göring believed German fighters could shoot down 4-engine bombers as easily as twin-engine aircraft. Milch disagreed. He called 1943 the year of clenched teeth. He predicted a crushing bombing offensive against Germany. He was right, but examining wreckage was different from flying an intact aircraft. Wreckage showed construction. Intact aircraft revealed performance. Wolfhound was the first complete flyable B-17 in German hands. The bomber had been repaired at Leeuwarden. German engineers replaced the damaged engines with Wright Cyclones salvaged from other crashes. They patched the bullet holes. They repaired the hydraulic systems. They made the bomber airworthy. 2 days after capture, on December 14, 1942, German pilots flew Wolfhound from Leeuwarden to Rechlin. 2. Messerschmitt Bf-110s provided escort. The bomber wore German national markings, black crosses on white backgrounds, swastika on the tail, but the flight was kept secret. No radio transmissions, low altitude, direct route. The bomber landed at Rechlin without incident. For the next 3 months, German engineers dismantled every system. They measured every component. They documented every design feature. They were looking for weaknesses, manufacturing techniques, materials used, engineering philosophies. What they found surprised them. The B-17 was not a revolutionary aircraft. It used conventional construction, aluminum semi-monocoque fuselage, riveted structure, nothing exotic. But the integration was sophisticated. The bomber combined multiple systems into a coherent whole that emphasized one specific mission profile: high-altitude daylight precision bombing with maximum defensive capability. Colonel Adolf Galland, chief of day fighter squadrons, had examined the earlier B-17 wreckage in October 1942. His assessment was blunt. The B-17 united a possible advantage in one bomber: heavy armor, enormous altitude capability, colossal defensive armament, great speed, 4 advantages that made attacking the bomber extremely difficult. Galland understood that conventional fighter tactics would not work. German pilots were trained to approach bombers from the rear and slightly below. That tactic worked against British bombers flying at night. It would not work against formations of B-17s flying in daylight at 28,000 feet with interlocking defensive fire. The defensive armament was what worried Galland most. The early B-17 models carried 7 to 10 50 caliber Browning machine guns. 50 caliber, 12.7 mm. Heavier than the standard German MG-17, which fired 8 mm rounds. The Browning 50 caliber could reach out 600 yards effectively. It fired armor-piercing incendiary rounds at 700 rounds per minute. A single gun could shred a fighter's engine, sever control cables, kill a pilot. Multiple guns firing simultaneously created kill zones that no fighter could safely enter. Baumbach walked toward the B-17 as Lerche shut down the engines. The sudden silence felt strange after the roar of 4 Wright Cyclones. Baumbach could see the bomber's gun positions clearly. Nose guns, 1 in the upper turret, 1 in the lower ball turret. Waist guns on both sides. Tail guns, every position manned during combat. Every gunner trained. Every gun loaded with hundreds of rounds of ammunition. This was not a bomber that needed fighter escort. This was a bomber designed to fight its way to the target and fight its way home. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Lerche climbed down from the cockpit. He was a small man, compact, efficient movements. Hound. The flight had lasted 90 minutes. He had tested climb rate, maximum speed, service ceiling, fuel consumption, handling characteristics at various altitudes. He had fired the guns. He had simulated combat maneuvers. He had pushed the bomber to its operational limits. Now Baumbach wanted his assessment. The 2 officers walked toward the hangar. Lerche spoke first. The B-17 was formidable, not because of any single outstanding characteristic, but because every system worked together to create a bomber that could survive fighter attacks through sheer defensive firepower. Lerche described the gun positions in detail. The nose position had evolved. Early B-17 models, the E and F variants, had limited forward-firing armament. Bombardier and Navigator each had a single 50 caliber gun. Those guns were mounted on flexible mounts. The gunner aimed by hand. Effective range was limited. Accuracy was poor. German fighter pilots quickly learned to attack from directly, ahead. Head-on attacks. The B-17's forward defenses could not stop a determined fighter making a frontal pass. But the Americans were solving that problem. Newer B-17 models, already in production, would mount a chin turret, two 50 caliber guns in a powered turret beneath the Bombardier's position, remotely operated, better fields of fire. That chin turret would eliminate the forward vulnerability. The upper turret was a different matter. Lerche had examined it closely. Sperry ball turret mount, 250 caliber guns, 360-degree rotation, excellent fields of fire above and to the sides. The gunner sat inside the turret and controlled both guns with hand controls. The turret could track targets smoothly. The guns could elevate from horizontal to vertical. Range was limited only by ammunition supply. 400 rounds per gun, about 30 seconds of sustained fire. The upper turret gunner was usually the flight engineer. He had the best visibility in the aircraft. He could see threats approaching from any direction except directly below. The lower ball turret covered that blind spot, another Sperry design, spherical, 4 feet in diameter, retractable. The gunner climbed in through a hatch in the fuselage. He sat in a fetal position, knees bent, back curved, face pressed against the optical sight. Two 50 caliber guns pointed downward. The turret could rotate 360 degrees. The guns could elevate from straight down to almost horizontal. The ball turret gunner was typically the smallest crew member. Larger men could not fit. The position was cramped, cold, isolated, but it protected the bomber's belly. German fighter pilots who tried to attack from below faced immediate fire from the ball turret. The waist gunners stood on both sides of the fuselage, open windows, flexible gun mounts. Each gunner had a single 50 caliber gun with 1,200 rounds of ammunition. That was more ammunition than any other position. The waist guns could cover beam attacks, fighters approaching from the side. The fields of fire overlapped. Both waist gunners could engage the same target if needed. The position was exposed. No armor. No protection except the gunner's flak jacket. Temperature at 28,000 feet could reach 42 degrees below zero. The waist gunners wore heated suits, oxygen masks, heavy gloves. They stood for hours in brutal cold, watching for threats, ready to fire. The tail position was the most isolated. A narrow tunnel connected the tail gunner's position to the rest of the aircraft. The gunner crawled through. He sat on a bicycle-style seat. He worked in a kneeling position. Two 50 caliber guns, 565 rounds per gun. The tail guns protected the bomber's most vulnerable approach. German fighters preferred rear attacks. Lerche explained that the tail gunner had a reflector sight, N8A model, better than the simple ring and post sights on earlier aircraft. The tail gunner could track targets precisely and engage at maximum effective range. Baumbach did mathematics. 12 50 caliber guns on the B-17F model that Wolfhound represented. The newer B-17G model would carry 13 guns, 13 times 700 rounds per minute, 9,100 rounds per minute combined, 151 rounds per second. Every second, 151 50 caliber bullets left those guns, armor-piercing incendiary rounds. Each bullet could destroy a fighter. The sheer volume of fire was overwhelming. A formation of B-17s, flying tight defensive boxes, could generate fields of fire that no fighter could penetrate safely. But Lerche had found weaknesses. The guns could only engage targets within their fields of fire. The nose guns could not fire directly rearward. The tail guns could not fire forward. The waist guns could not depress far enough to engage fighters diving from directly above. A skilled fighter pilot could identify the gaps and exploit them. Head-on attacks remained effective if executed before the chin turret became standard. High deflection attacks from above and ahead, forced gunners to track targets through difficult angles. Attacks from the sun blinded gunners. Attacks using clouds for concealment allowed fighters to close range before gunners could react. The bomber's defensive firepower was also limited by ammunition. Wolfhound carried approximately 5,000 rounds of 50 caliber ammunition. 9,100 rounds per minute combined fire rate meant the bomber could sustain full defensive fire for about 33 seconds, half a minute. In reality, gunners fired in bursts, aimed shots, conservation of ammunition. But sustained combat drained ammunition quickly. A B-17 isolated from its formation and fighting alone would exhaust ammunition within minutes. After that, the bomber was defenseless. Lerche also identified a critical vulnerability. The crew, 10 men. Flesh and blood. The bomber had armor around critical positions. The pilot's seat had armor plate behind it. The tail gunner had armor protection. But armor was limited. Weight restrictions meant protection was selective. Most crew positions were unprotected. A 20mm cannon shell exploding inside the fuselage killed crew members. Dead gunners meant silent guns. Silent guns meant unopposed attacks. The bomber's defensive concept required every gun position to remain operational. Lose one position and the defensive coverage developed gaps. Lose multiple positions and the bomber became vulnerable. The engines were another concern. 4 Wright Cyclone R-18, 20 radial engines, 9 cylinders each, air-cooled, 1,200 horsepower per engine, reliable engines, but vulnerable to battle damage. A German fighter armed with 20mm cannons could disable an engine with a single burst. The B-17 could fly on 3 engines. It could even maintain altitude on 2 engines. But with engines damaged, the bomber lost speed, lost altitude capability, became easier to attack, became more difficult to return to England. Baumbach and Lerche entered the hangar. Inside, German engineers had disassembled parts of another B-17. This one had crashed and could not be repaired for flight, but the wreckage provided detailed information about construction techniques. Baumbach walked through the components. He examined the armor plating. 1/4-inch steel behind the pilot's seat, thicker plates protecting the tail gunner. The armor was well positioned but limited in coverage. He examined the fuel tanks. Self-sealing design, rubber lining inside each tank. When punctured, the rubber swelled and sealed small holes. That prevented fuel fires. British bombers had similar tanks, but the American implementation was more sophisticated. Multiple layers of rubber and fabric. Better sealing. Characteristics, longer operational life. He examined the oxygen system. High-altitude bombing required oxygen above 10,000 feet. The B-17 carried multiple oxygen bottles. Regulators for each crew position. Backup systems. Redundancy built into every critical system. American engineers designed for survivability. German engineers designed for performance. Different philosophies. The American approach meant heavier aircraft but better survival rates. The German approach meant lighter aircraft but higher vulnerability. Baumbach had been flying combat operations since 1939. He had commanded bomber units over Poland, France, Britain. He understood strategic bombing from both theoretical and practical perspectives. He recognized that the B-17 represented a different approach to air warfare. The British bombed at night. Individual aircraft, dispersed, no formations. Night bombing avoided fighter interception but sacrificed accuracy. The Americans bombed, in daylight. Formations. Tight defensive boxes. Maximum defensive firepower. Daylight bombing meant fighter attacks but allowed precision targeting. The American strategy required bombers that could survive determined fighter opposition. The B-17 was designed specifically for that mission. Every aspect of the aircraft supported the concept. High-altitude capability kept the bomber above most flak. Heavy defensive armament discouraged fighter attacks. Self-sealing fuel tanks and armor protection improved survival rates. Redundant systems allowed the bomber to absorb damage and continue operating. The B-17 was not the fastest bomber, it was not the highest flying bomber, it was not the most heavily armed bomber, but it integrated all necessary capabilities into one aircraft that could execute the mission repeatedly. Baumbach understood what the B-17 meant strategically. The Americans were preparing to attack Germany in daylight. They would bomb factories, refineries, and transportation networks. They would destroy Germany's industrial capacity. The Luftwaffe would have to stop them. But stopping formations of B-17s required tactics that did not yet exist. Conventional rear attacks were suicide. The defensive firepower was too intense. Head-on attacks worked better but required precision timing and nerves of steel. A fighter attacking head-on closed with the bomber at combined speeds exceeding 600 miles per hour. The pilot had perhaps 2 seconds to aim and fire. Miss that window and the bomber's gunners would shred the fighter as it passed overhead. Galland had already begun developing new tactics. Concentrated attacks by entire fighter squadrons, simultaneous approaches from multiple directions to overwhelm the gunners, use of heavy cannon armament to engage bombers beyond the range of their defensive guns, rockets fired from outside effective defensive range. Every tactic aimed at the same goal: destroy enough bombers to make daylight operations unsustainable, force the Americans to abandon their strategy. But Galland also understood mathematics. American industrial capacity was enormous. They could build bombers faster than Germany could shoot them down. They could train crews faster than the Luftwaffe could kill them. The material advantage would eventually determine the outcome. That afternoon, Lerche flew Wolfhound again. This time, German fighter pilots joined the exercise. Messerschmitt Bf-109G models. The latest variant, better performance at high altitude, heavier armament. The fighters would practice attack tactics while Lerche and a skeleton crew defended the bomber. The exercise was carefully controlled. Live ammunition would not be used, but the pilots would learn how the B-17 responded to different attack profiles. They would identify blind spots. They would measure closing speeds. They would develop techniques that could be taught to every fighter pilot in the TOLD, Luftwaffe. The fighter pilots were experienced veterans. They had flown combat over Britain during the Battle of Britain. They had fought on the Eastern Front. They had engaged Allied bombers over France and the Low Countries. But attacking Wolfhound was different. The bomber was isolated. No formation to provide supporting fire. No other bombers to distract the gunners. The fighter pilots could focus entirely on attack techniques without worrying about being shot down. They could experiment. They could fail. They could learn. The first fighter approached from the rear and slightly below. Classic attack profile. The pilot closed to 600 yards. That was the effective range of the defensive guns. The tail gunner, played by a German gunner familiar with the American systems, tracked the fighter smoothly. The tail guns remained on target throughout the approach. The fighter pilot broke off the attack at 400 yards. In real combat, he would be dead. The defensive fire would have shredded his aircraft. The tail guns had clear fields of fire, and the gunner had tracked him perfectly. The second fighter tried a beam attack. Approaching from the side at bomber level, the waist gunner tracked him. The upper turret gunner tracked him. Both guns remained on target. The fighter pilot had perhaps 3 seconds of firing time as he passed the bomber. But during those 3 seconds, 2 defensive guns were firing back. The exchange would be simultaneous. The fighter might hit the bomber, but the bomber would definitely hit the fighter. Not an acceptable trade-off. The third fighter tried a high deflection attack from above and ahead, diving out of the sun. The upper turret gunner struggled to track the target. The nose gunner engaged late. The fighter had a brief window, but the attack required extreme precision. The fighter dove at high speed. The deflection angle changed rapidly. The pilot had to lead the target perfectly. Miss by a few degrees, and the bullets passed harmlessly ahead of the bomber. The attack was possible but required exceptional skill. The fourth fighter tried a head-on attack, level approach from directly ahead. The nose guns engaged at 800 yards. The fighter pilot held steady. 600 yards, 400 yards, 200 yards. The closing speed was over 600 miles per hour. The pilot had approximately 2 seconds to fire before he had to break away or collide. During those 2 seconds, the nose guns were firing continuously. The fighter pilot would be flying through a stream of 50 caliber bullets. Some fighters would survive, most would not. Head-on attacks worked, but they cost fighters. After 90 minutes of simulated attacks, Lurch landed Wolfhound. The fighter pilots gathered in the briefing room. The mood was subdued. They had just learned what every Luftwaffe pilot would learn over the next 2 years. The B-17 Flying Fortress earned its name. One bomber alone was dangerous. A formation of B-17s was nearly impregnable. The defensive firepower was simply overwhelming when multiplied across dozens of aircraft flying in tight formation. Baumbach asked each pilot for their assessment. The responses were remarkably consistent. Attacking from the rear was suicide. The tail guns had clear fields of fire and excellent visibility. The tail gunner could track targets easily. Any fighter that pressed an attack from the rear would be destroyed before reaching firing range. Beam attacks offered slightly better chances. But the waist guns and upper turret covered those approaches. The gunners had overlapping fields of fire. A fighter attacking from the beam faced multiple guns simultaneously. High deflection attacks from above required exceptional skill and offered limited firing opportunities. The attacks had to be executed perfectly. Timing was critical. Deflection angles changed rapidly. Most pilots could not make those shots consistently. Head-on attacks offered the best chance of success. The forward defensive armament was weakest, but head-on attacks required courage bordering on recklessness. Flying directly toward a bomber at combined closing speeds exceeding 600 miles per hour violated every survival instinct. The pilot had to hold steady while defensive guns fired at him. He had to aim precisely during a 2-second window. Then he had to break away before collision. Many pilots would die learning that technique. One of the fighter pilots, Lieutenant Klaus Fischer, made an observation that summarized the fundamental problem. He said a single B-17 was difficult to destroy. A formation of B-17s supporting each other with interlocking defensive fire was nearly impossible to destroy without accepting catastrophic fighter losses. The Americans understood this. They trained their crews to fly in tight formations specifically to maximize defensive coverage. Every bomber protected the others. Gaps in one bomber's defensive coverage were filled by guns from adjacent bombers. A fighter, attacking any bomber in the formation, faced fire from multiple aircraft simultaneously. Baumbach had seen formations of British bombers at night. Individual aircraft. Dispersed. Each bomber flew alone and defended itself alone. The British accepted losses of 5% per mission, sometimes 10%. Those losses were sustainable because British bomber production could replace them. But the British bombed at night when German fighters had difficulty finding targets. The Americans would bomb in daylight. Their formations would be visible for miles. German fighters would have no difficulty finding them, but finding them and destroying them were different problems. The Americans were preparing to send hundreds of B-17s against Germany, maybe thousands eventually. Each bomber carried 10 crew members. Each bomber carried 6,000 pounds of bombs. Each bomber cost $200,000 to build. But most importantly, each bomber carried 1350 caliber machine guns. Multiply 13 guns by 100 bombers, 1,300 defensive guns, all firing simultaneously, all engaging any German fighter that approached the formation. The mathematics were brutal. German fighter pilots would face defensive fire unlike anything they had encountered. Galland understood the implications immediately when Baumbach briefed him on the Rechlin tests. The Luftwaffe would need new tactics, new weapons, and new training. Fighter pilots could no longer approach bombers casually. Every attack had to be planned. Every approach had to exploit specific weaknesses. Pilots had to work together in coordinated attacks. Individual heroics would get pilots killed. The Americans had created a weapon system that required systematic German response. Improvisation would not work. The defensive firepower was too intense. If you find this story engaging, please take a moment to subscribe and enable .tome notifications. It helps us continue producing in-depth content like this. April 17th, 1943, 0600 hours. Over the North Sea. Major Egon Meyer led 12 Messerschmitt Bf-109G fighters toward England. His unit was Jagdgeschwader II, one of the Luftwaffe's most experienced fighter wings. Meyer was 29 years old. He had flown combat since 1940. He had shot down 86 Allied aircraft. He understood fighter tactics better than almost anyone in the Luftwaffe. And he had developed a technique that would change how German fighters attacked B-17s. Meyer had studied the intelligence reports from Rechlin. He had read Lurch's detailed analysis of Wolfhound's defensive capabilities. He understood the weaknesses. Forward defensive armament was inadequate on the B-17F model. The bombardier and navigator each had a single 50 caliber gun on flexible mounts. Those guns could not cover the entire forward hemisphere. A fighter attacking from directly ahead, slightly above or slightly below the bomber's center line, faced limited defensive fire. The nose guns had to be aimed manually. Tracking a fighter approaching at 600 miles per hour combined closing speed was nearly impossible. Meyer had developed a tactic he called the Kopfjagd, head hunting. His fighters would form a line abreast formation several miles ahead of the American bomber formation. When the bombers came within range, all 12 fighters would attack simultaneously from head-on. They would dive slightly, building speed to over 400 miles per hour. They would open fire at 600 yards with their 20mm cannons. They would hold their fire until 200 yards. Then they would break away, splitting above and below the bomber formation. The entire attack would last 5 seconds. But during those 5 seconds, 12 fighters would pour cannon fire into the front of the American formation. The tactic worked. On April 17th, Meyer's unit intercepted a formation of B-17s from the 306th Bomb Group returning from a raid on Bremen. Meyer executed his head-on attack perfectly. His fighters destroyed 4 B-17s and damaged 6 others. German losses were 1 fighter damaged. The kill ratio was unprecedented. Meyer had found the answer to the B-17's defensive firepower. Attack from ahead, attack in groups, attack fast, break away before the bombers could respond effectively. Word spread quickly through the Luftwaffe. Head-on attacks became standard tactic. Fighter units practiced the technique. Pilots learned to overcome their instinct to break away early. They learned to hold their aim while flying directly toward 4-engine bombers. They learned to break away at the last possible moment. The tactic required discipline and courage, but it worked. German fighter pilots began shooting down B-17s at rates that shocked American planners. The Americans responded. Boeing engineers accelerated development of the B-17G model with the chin turret. 2 50 caliber guns in a powered turret beneath the bombardier's position. The chin turret could engage fighters attacking head-on. It covered the forward defensive gap. The first B-17G models reached England in September 1943. The chin turret eliminated the forward vulnerability that Meyer had exploited. German fighter pilots found themselves facing defensive fire from every approach angle. The B-17 had become even more formidable. Back at Rechlin, German engineers continued studying Wolfhound. They tested every system. They measured every performance characteristic. They documented everything. One engineer, Oberingenieur Friedrich Ebert, focused specifically on the defensive armament system. Ebert was a weapons specialist. He had designed gun installations for German bombers. He understood the engineering challenges of mounting multiple, heavy machine guns on aircraft. What impressed him most about the B-17 was the integration of the defensive system. American engineers had solved problems German engineers were still struggling with. The turret mounts were sophisticated. They rotated smoothly. They tracked targets accurately. The guns were reliable. 50 caliber Brownings almost never jammed. They fired in extreme cold. They fired at extreme altitude. They required minimal maintenance. German machine guns, especially the MG-131, were more prone to jamming. They required more careful maintenance. They were less reliable in combat conditions. The ammunition supply system was elegant. Each gun position had dedicated ammunition boxes. The boxes fed ammunition through flexible chutes. The chutes allowed the guns to move through their full range of motion without tangling. German engineers used similar systems, but the American implementation was more refined. Better materials, better engineering, tolerances, fewer failure points. The defensive system worked as an integrated whole. That integration was the key to the B-17's effectiveness. Ebert wrote a detailed technical report. He described every component of the defensive system. He explained the engineering philosophy behind the design. He noted that American engineers prioritized reliability over performance. German engineers typically prioritized performance over reliability. German weapons were often superior in raw capability, but American weapons were more dependable in sustained combat operations. That reliability mattered more than theoretical performance. A gun that fired every time was more valuable than a gun that occasionally jammed but had higher muzzle velocity. The report circulated through German military and industrial circles. Some engineers dismissed Ebert's conclusions. They believed German engineering was superior. They claimed German weapons were better designed. But the combat results contradicted those claims. B-17s were surviving fighter attacks. German bombers were not surviving Allied fighter attacks at comparable rates. The difference was not courage or tactics. The difference was industrial capability and engineering philosophy. Field Marshal Milch read Ebert's report. He understood immediately. Germany was losing the industrial war. American factories produced aircraft faster than German factories. American production was standardized, interchangeable parts, assembly line techniques, simplified designs that prioritized production speed over engineering elegance. German production was artisanal, custom components, hand-fitted parts, complex designs that required skilled labor. German aircraft were often superior individually, but American aircraft were superior collectively because there were so many more of them. The B-17 represented everything Germany could not match: industrial-scale production, reliable systems, integrated design philosophy, sustainability in combat operations. Germany could build individual aircraft that outperformed American aircraft. The Focke-Wulf 4190 was superior to the B-17 as a pure flying machine, but Germany could not build enough 4190s to stop American bomber formations. Industrial capacity determined outcomes. The country that could build more weapons faster would win the war of attrition. Germany could not win that war. By late 1943, American bomber formations were attacking Germany regularly, hundreds of B-17s flying in defensive boxes. German fighters attacked using every tactic Rechlin had identified: head-on attacks, high-deflection attacks from above, coordinated squadron attacks, rocket attacks from outside defensive gun range. The Germans shot down bombers, but not enough bombers. American production replaced losses faster than German fighters could inflict them. The intelligence gained from Wolfhound helped the Luftwaffe develop effective tactics. Those tactics reduced German fighter losses and increased American bomber losses. But the tactical improvements could not overcome the strategic disadvantage. Germany lacked fuel. Luftwaffe fighter units were often grounded because fuel stocks were depleted. Germany lacked pilots. Training programs could not replace experienced pilots killed in combat. Germany lacked aircraft. Factories were bombed. Production declined throughout 1944 and 1945. The material disparity widened month by month. Wolfhound remained at Rechlin through 1944. German pilots continued flying the bomber for training purposes. New fighter pilots flew simulated attacks against the B-17 before deploying to combat units. The training saved lives. Pilots who understood the bomber's capabilities survived longer. Pilots who learned the blind spots could attack more effectively. But training could not replace industrial capacity. Knowledge could not replace fuel. Tactics could not replace numbers. On April 21, 1945, Soviet forces captured Rechlin. German personnel destroyed most equipment before evacuating. Wolfhound was burned. German engineers set fire to the bomber rather than let it fall into Soviet hands. The B-17 that had revealed so many secrets to Germany became another casualty of a war Germany had already lost. The wreckage was eventually scrapped. No pieces survive. Only photographs and technical reports document the bomber's existence and its role in German intelligence efforts. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.